The two most recent calendar years whose digits are all even are 2000 and 2002. Well, this contest was from 2003, so that's why they're saying that. What was the most recent year before 2000? Okay, well, every year before 2000 starts, I guess, from 1999 and going backward, right? But the 1 is not even. It's an odd number. So everything from the year 1000 to the year 1999 would not qualify because of that 1. So we got to go even before the year 1000. Okay, so that means we're now into 3 digits. And, well, the 9 is obviously odd. So we got to go down to the 8s. And then if we go down to the 8s and there's 3 digits, we can't put a 9, but we can put an 8. And if you think about this, you'll conclude that that is indeed the most recent year before 2000, where all digits are even. In my bedroom bookcase, 37 books are in German, 36% of the books are in Spanish, and the remaining books are in French. If the ratio of Spanish to French books is 4:3, how many books are there altogether? So let's say there's a total of n books. 37 are German. Okay? And then they're saying 36%, so the 0.36 of n is Spanish. And then the remaining, that's what they say. They don't say an actual number, are French, but we have to give some sort of a value to it. So it'd be n, the original n, minus 37 German books, and minus the 0.36 n Spanish books. Okay? So that's representing the French books. And then they're saying that 4:3 is the ratio of Spanish to French books. So Spanish is 0.36 n, and French is n minus 37 minus 0.36 n. And that is the algebra that we are going to have to work with. Cross multiplying, you get 3 times 0.36 n. On the other side, you will get 4 times n minus 37 minus 0.36 n. Got it? 1.08 n is equal to 4n minus 148 minus 1.44 n. So therefore, let's see, 148, put all the n's on one side, and that would be 1.48 n, and therefore n, when you divide through, will be 100. So there's 100 books on the bookcase. When one of the 20 numbers was increased by 100 and the other 19 numbers remained the same, the average of the 20 numbers was tripled. What was the average of the original 20 numbers? So we have x1 plus x2 all the way up until x20. And when you take the average, of course, you divide by 20, and that is some average. I'll just call it a. Now, this whole thing, I don't want to keep writing it out again and again, so I'll just call it sum. Okay. So then what they've done is they've just taken one of these 20 numbers and increased it by 100. So let's just say that is the 20, and they've increased it by 100. So then what you have is this whole sum plus just an additional 100. And they're saying now this average, which again you divide by 20, so there's still only 20 numbers, that average is tripled. So basically what that means, it's 3a. Okay? And then they're saying what is the average of the original 20 numbers? So basically what they're saying is what is a? Okay, so this is what I have to work with. So let's see here. Let's break this up into sum over 20 plus 100 over 20. And that's 3a. Now sum over 20 is this guy right here. Sum over 20. Here's the sum, here's the 20, and that's a. So this is just a, and this is 5. So you see how nicely that works out? So 5 therefore equals 2a, and a is therefore equal to 2.5. What is the smallest positive integer which uses only the digits 0 and 1 and is divisible by 225? So we have some integer n, it's divisible by 225, so obviously it's a multiple of 225. Now 225, if you break it up into its prime factors, it would be 5 times 5 times 3 times 3, and then multiplied by some factor k. Okay, this is what we have to work with. There really isn't much. So what I'm going to do, let me think about this. What can I do here? Well, these 5s, we want an n to have only zeros and ones, right? So whatever, like 1, 0, 0. Like, I have no idea what n is, but like this is an example of a number that has only zeros and ones. So there's no way it can end in a 1, because a multiple of 225 would always end in either 5 or 0, right? You can try it. Just go 225 plus 225, it would be, well, I can write it here, 225, and then the next multiple would be 450, the next multiple would be 675, the next multiple would be 900, and so on, right? So as you can clearly see, the last digit is always going to be 0 or 5. Now, we can only have zeros and ones. So that means my n, whatever that n is, has to end in a 0. Okay, so that is decided. So if it ends in a 0, that means that there's got to be some 10, a factor of 10 in n. So n has to be 10 times something. And the way I can get a 10 is by making k equal to a 2. Like there's going to be a factor of 2 in the k. And then that will take care of this guy. It will make it 2 times 5, which is 10. But then we also have to take care of that guy because we can't have a 5. So let k have 2 2's. So that would make it 5 times 5 times 3 times 3 times 2 times 2. And then times some k2. I mean, k, I have no idea what k is. So k could have other factors. But what that does is it allows you to combine those 5 and the 2's to make them 10 and 10. 5 times 2 is 10, 5 times 2 is 10. And then this 3 and the 3, we'll just leave that there for now, and then we got this k2. So then that really just becomes 100 times 9 times k2. So that basically means that the n, whatever it is, I have no idea, it ends in 2 zeros. Yeah, because of this 100. Okay, we got that far, but we're nowhere near to getting the number. Now what we have to do is we have to use something called divisibility rules. Divisibility, a lot of I's in that. Divisibility rules, and in particular, the rule for 9. So the divisibility rule for 9, so if n is divisible by 9, that basically means that the sum of the digits is also divisible by 9. Divisible by 9. So since our digits are only 1 and 0, and they want the smallest, what if I put in 9 ones? So 1, 1, 1, 1, 1, 1, 1, 1, 1. Let me write it here. So 9 ones, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then it has to end in that 2 zeros because of this 100. This number qualifies. It is definitely a multiple of 225. You can check in your calculator if you're not convinced. It's just 225 times 493827716. And it consists only of zeros and ones, and it is, and that's it. Those are the only two criteria. It is a multiple of 225, and the number only consists of zeros and ones. Now, the key thing is that it's the smallest. Now, you can keep going, right? You could have another much larger number that would satisfy the criteria, but this is the smallest. So therefore, that is the number. And if you want to complete it with commas, there you go. What is the largest value of k less than 9 for which there is a polynomial y is equal to f of x, which with integer coefficients whose graph passes through 3, 9, and 8k? All right, well, we don't know what is the polynomial, meaning is it a linear, which would be y equals mx plus b? Is it a quadratic, which would be, ax squared plus bx plus c. Is it a cubic function, which would be ax cubed plus bx squared plus cx plus d? I have no idea. That's, I guess, the challenge of the question. So since I don't know, I'm just going to start with this guy, and if that fails, I'll move on to the next guy. So let's start with y equals mx plus b and see if we can do this or not. So if y equals mx plus b is the equation of this polynomial, then these two would satisfy that equation. So let's see here. That would be 9 is equal to 3m plus b, and k is equal to 8m plus b. Correct? Okay. So let's solve these two. If you subtract them, it would be k minus 9 is equal to 5m. The b's disappear. And therefore k is equal to 5m plus 9. All right. Now, they told me that k is less than 9. And is k an integer? What is the largest value? No. Integer coefficients. Integer coefficients. Okay, so if it integer coefficients, that means that is a coefficient. M is a coefficient. I think that's the right way of thinking about it. So that means in order to get values of k, I can just put in integer values of m. Okay, so let's start with m equals 1. Let's see what happens. And m is 1, k would be 14. Okay, that fails because k has to be less than 9. No problem. Let's keep going. If m is 0, for example, if it's a horizontal line. Horizontal line would have a slope of 0. If m is 0, k is 9. Okay, that still fails because k has to be less than 9. How about m equals negative 1? That would make k equal to 4. And that would be the largest value, because you can keep going. Like if m is negative 2, then k would be minus 1 and so on. But this is the largest value. Okay, but I want to make sure that this is correct. So let me substitute k back into these equations. So this was for m equals negative 1, right? So if m equals negative 1, then 9 is equal to, and for this equation, minus 3 plus b. And then for this equation, it would be 4 is equal to minus 8 plus b. Well, that just gives you k is 12, and that also gives you, sorry, b is 12. So that means the equation, the original equation, not that it's needed, but I just wanted to complete it for the sake of making this question complete, would be y is equal to minus 1 times x plus 12. Yeah. And that is satisfied with k equals 4 for the conditions in the question. Two perpendicular diameters are drawn in a circle. Another circle tangent to the first at an endpoint of one of its diameters cuts off segments of lengths 10 and 18 from the diameters as in the diagram. How long is the diameter of the circle? Okay, well, let's just work with the diagram they gave me. And I'm going to have to do some labeling, though. Well, the 10 and 18 are already labeled. So this little distance I'll call y. This I'll call x. And I'm going to draw the center of that smaller circle. And therefore, this radius I'll call r. This distance will therefore be r minus x. And I think that should be sufficient. Let me see if I labeled everything. Yeah, and one more thing I would like to label. First, I'm going to draw a line. That line right there, and that, as I'm sure you can figure out, is also small r. I think that should be good enough. Now, they want us to find the diameter of the larger circle. So if r is the radius of the smaller circle, I'll let big R be the radius of the big circle. So the diameter would therefore be 2 times big R. So this is basically what we're trying to figure out. Okay, so then that is decided. So let's see if we can come up with some equations. What equations can we come up with? Well, the big R looks to me as the same as y plus 10, right? And then the big R also looks the same as 18 plus x. And then another equation I guess I could come up with is that the big R is also the same as r minus x plus r, which is the same as 2r minus x. Just looking at different parts of the circles. And then anything else? Let me think, there's anything else here. The big R, I think that's good enough. And then all the way across, 18 plus 2r, yeah, would be the same as 2 of the big R's. And that would basically be 9 plus r is equal to r. So let me label this 2, 3, and then 4. So these are my 4 equations that I can get directly from the graph. Okay, that's pretty decent. And then one final equation I get through Pythagoras, and that is the whole point of that triangle. I'll just draw that triangle again here. This was y, this is r minus x, and this is r, and that was a right angle, as they even show in the diagram. So from that, you can get a Pythagorean relationship, that y squared plus r minus x squared is equal to r squared. And that's going to allow us to solve for the numerical value of small r and big R. Okay, so let's substitute it in. For y, well, y squared, I'm going to have to do a little bit of, before I sub it in, I have to actually calculate it. Well, r is equal to 9 plus r, right? So that means that if I sub that in, that would mean 9 plus small r is equal to y plus 10. So that means y is equal to r minus 1, correct? Yeah, so then r minus 1 goes here. Okay, that's actually pretty good. And then we'll do the same thing with this one. So 9 plus r is equal to 18 plus x. So that means x is equal to r minus 9. Yes, so then r minus 9 all squared. And that equals r squared. There you go. We got everything in terms of one variable, and that allows me to solve. So here we go. So that's going to be r squared minus 2r plus 1. That just becomes 9 in the bracket, so that just becomes 81 when you square it, and that's r squared. So the r squareds cancel, so that you get 82 is equal to 2r, and therefore r is 41. And then that tells me that big R is 9 plus small r, so that'd be 9 plus 41, which is 50. And finally, since we want d, which is equal to 2r, 2 big R, that'd be 2 times 50, and that is 100.